Okay, so let's start in English now. And one little announcement in the page, in the course page. Let me share it with you. Here. Now you should be seeing the course website. The professor uploaded another survey or another thing that you need to answer. Let me check so you can. It's not in announcements. This one, the university-wide survey. Let me click. I'm not sure how many of you have responded this survey, because it's very important that you do to have feedback. You can see it here in the course website. You need to click that link and you'll be redirected to the survey monkey page, and you need to answer this survey. It has a lot of questions, but please, I encourage you to do it. It's very valuable for us. Daniel Solomon is saying that I'm too quiet. How are you hearing me now? Maybe here. Now? How do you hear me? Okay, so maybe Daniel. Oh, he solved it already. Okay, so try to finish this survey, please, and now we'll start with the math-related topics. As Christine requested, we'll start with the solutions of the part we already did of the TA, and then we'll do the part about random number generation and all over again. For two reasons: one, that that part of the tutorial was not recorded, as Javiera already said, and also because we want to do the activities. So let's start. Okay, let me change something here. Now it's okay. So the first part is the activity 1 of the past tutorial, and it was about the interpolation of polynomials when you had, for example, some equations that the polynomial needed to satisfy, and the whole objective of this question was to find the vector C such as the matrix A times C equals to B. The first part of the question or the activity was to see if the equations or the system was underdetermined, overdetermined, or just a square system. For that, you can do it programmatically by doing the matrix rank function. So we define the matrix here, as we already did the last tutorial. You obtain 4 rows. Each row is an equation of the part of the activity, and B is the values that each equation had to satisfy. And when you do matrix rank of A, you see that the rank of A is 4, but the number of equations is 5. That means that the system is subdetermined. What that means mathematically or in the activity is that you cannot solve this this problem by using the solve function that does the inverse of the matrix A, because the matrix is not a squared matrix, and therefore you need to use the least squares method that we already have seen, that you can do it by this function, least squares. And if you get the first output of this function, you obtain basically the solution. Then, to plot that, you just needed to put each coefficient multiplied by x squared, and so on, the same as the part before, this part. I'm just basically programming this part to plot the polynomial. And you do that with the solution of the coefficients. And then I also plotted these 2 points that are the points that you basically needed to satisfy. You can see before here that at 0 the polynomial must be 0. That means the point 0, 0 is in the polynomial, and here 1, the polynomial evaluated in 1 is 1. That means that the point 1, 1 is also in the polynomial. And as you can see here, the point 0, 0 and 1, 1 are part of the polynomial, and you see the interpolation here. That's the result. For the part of the images, I'll let that as a homework or exercises if someone wants to do it, because today we'll start working in the homework. I'm not sure how many of you have seen it, but I think we'll skip this part to give more time to the homework. That's better for you, I guess. And now we'll start the part about random number generation. Everyone agrees that it's better to do the homework instead of this problem that is a little bit long? Yes? Okay, fantastic. We've already seen this, but I'll say it again so it will be recorded in the video. We basically had in the tutorial 2 types of distribution. The first one was the uniformly distributed random variable. Basically what it means is that you have an interval a, b, this one here, and you roll a dice that gives you a number between a and b, and each number in the interval, it has the same probability of occurring. Specifically, the probability, you can express it as 1 over b minus a. So the probability density function integrates 1. And in Python, you can use this type of random variable by using the function random uniform, and then the low bound is basically this a, by default is 0, and the higher bound is 1. That would be the b in this example. And the size is how many of these random events you want to simulate. So for example, here I'm importing the random uniform function, and if I put size equals to 10, I simulate 10 random numbers between 0 and 1. As you can see here, if I run it again, the number, all the numbers changes. That's good because we want random numbers. So it will not be the same each instance of this vector. If we use instead of 10, 10,000, and we do the histogram of these numbers, x, here you can see that the uniformly distributed PDF is this yellow line, and the histogram of these x instances of the uniformly distributed PDF are here in blue. So they are very similar of what they should be. That's good. And then we also had the normally distributed data. Basically, the PDF is this one here. That's what it's called a Gaussian distribution or normal distribution. And if you change the parameters mu and sigma, what you're changing is the location of the peak in the PDF, and also the variance, obviously, but that means that it gets wider or thinner. If you have a bigger variance, you'll get a more fat distribution, but it's shorter. It's like short and fat with high variance, and if you have low variance, it's tall and thin. And basically these parameters mu and sigma are called in the normal function here with the parameters log of location, and scale is basically the sigma. I'm not completely sure, I didn't search it online, if this scale parameter in this method is related to the variance, that means the standard deviation squared, or the standard deviation. You need to see that in the documentation, or we can see it right now. It's better. And as the same as the uniformly distributed random numbers, you also have a size part that you could do to have more instances of this number or this variable. The same as before, instead of putting uniform, you put normal, size equals to 10, and then you get 10 uniformly distributed random variables. And if we wanted to see what the scale parameter means, you do shift tab inside the function, you click plus, and we see here a scale, and scale is the standard deviation. So now is settled. The scale parameter in this function is related to the standard deviation of the distribution. If we do the same as before, 10,000 numbers now, and we plot the histogram of this big vector. And when we compare the PDF of the random number generator, it's very similar to the histogram, and that's desired, of course. I think I forgot to import this part. Yeah. A very common application of random numbers, and specifically normally distributed random numbers, is the white noise, or electronic noise in general. Because in electronics, when you measure something using a sensor, what you're doing is measuring something with a little cable, and that cable has little electrons moving randomly because of the temperature, and that little movement gives a little of thermal noise in the measurement, because the movement gives you tiny variations in voltage, and you can see that as a normal distribution. Why is a normal distribution? Because you assume that each tiny variation in voltage is identically distributed in all the electrons, and when you do the central limit theorem, you get a Gaussian distribution. So basically that's why you obtain something like this. As I already said before, this noise is what you usually hear when you have, for example, the radio with no valid station, and it sounds like that's usually white noise. You're measuring, or what you're hearing is the tiny movements of the electrons due to temperature. If the temperature is bigger, that noise or that sound would be bigger or louder. Okay, so now we'll do the activity. Please open the here in the course website, open the last document I uploaded in the tutorials part here, tutorial 3 solutions and tutorial 4, and we'll start working. Just to remember you how to do it, you just open it and then select the here in file, and I'm not sure how it was called, playground mode, and you can start editing the notebook. And we'll also be doing groups. So now I'll split the conference in multiple conferences. Any doubts before doing that? Everything was clear? Okay, I'll send you directly. Let me open it, and okay. It's possible that you have problems because you are not logged in with a institutional email. So try to open it. Okay, so it should be fine. If you have any problem, just tell me. Okay, another doubt before starting the activity? Yes? Mm-hmm. Okay, let me clarify that. Okay, so for uniformly distributed numbers, when you use the uniform function, by default, it gives you a number between 0 and 1. But with these two parameters, the low and high parameters, you can change the interval of what you want. You can put low equals to -1 and high equals to 10, whatever you want. For the yes, you need to change the parameters. For example, you change it as low equals to -1, high equals to 10, and now the numbers are between -1 and 10. Here you can see a 9, 0. Let me put it between -5 and 10, and you can see now negative numbers. Another way to do the same is just to multiply the random variable, because if you do it between 0 and 1, this variable here, x, it will be between 0 and 1. But for example, 2x, it will be between 0 and 2. And then, for example, 2x minus 1, it would be between -1 and 1. So you, oh, here I forgot the x. Here. So you could change the interval by doing mathematical operations, or just by changing the low and high parameters of the function in the uniformly distributed random generator. For the Gaussian distribution, by default, the Gaussian distribution has values between -infinity and infinity, but it's very unlikely to have very low negative numbers or very high positive numbers. But for example, here, if I run it a few times, here you can see a -3 now. And if I run it again, it could be 100 here. It could be any number. And to basically vary the distribution, you need to change the location. This is the mean and the standard deviation. So for example, if the mean of the distribution is 0, it will give you most likely between -1 and 1, for example here, because in the red line, the standard deviation is 1, and primarily the distribution will give you numbers between -1 and 1, but you also have these tails that you could obtain numbers between -1 and -infinity, for example. So in the uniformly distributed PDF, you just obtain numbers in an interval. In the normally distributed data, you obtain numbers between -infinity to infinity, but it's very likely that you obtain numbers in the mean. If the mean is -2, the numbers will vary slightly in that range, -2, -2, -sigma, so on. I'm not sure if I answered your question. Okay. So let's start then. Let me break the rooms. How many rooms I had last time? I forgot. Someone remembers? No? Okay, so we have 10 participants. Let's do 3 rooms. Yeah. Okay, let's start with the activity. you need to import the legend function in the first line. No, in that cell, yes. At the most right part of the line, you need to add a comma legend. No, no, no. Here. There. There it is. Mm-hmm. Mm. Let me see. I don't remember the question. Yeah, you need to simulate multiple of x's. Let's try with 1,000. Yes, 1,000. You change the size to 1,000. Okay, so let me control your computer. In this part, in the size, you can, for example, put 100, and now you have 100 random numbers. So let's try with 1,000, but when you have so many numbers, you don't need to display the vector. So let's remove the x part, and then you have that x. It has 1,000 uniformly distributed random variables between 0 and 1. Yes, you need a lot of numbers to do a histogram, because if you, for example, just have 10, the histogram will not be similar to the PDF. Yes. Okay. Continue working. I'll change to the other room. How are you guys doing? Oh, that's that's the main thing about the dice part. The uniformly that function uniform does not do integers. It does like real numbers between 1 and 6. You could round the result. Round? You could round the result. Oh yeah, yeah. That does the floor function. But I think there's a uniform int. Look at that. If you remove the uniform part and press tab, it will try to autocomplete the functions. Then dot tab. I think there's a function that is called uniform integer or something like that, or integer uniform. I'm not sure how it's called, but or random int. Yeah, rand int. That's the function you want to use. Uh, it could be important, but not necessarily. If you are not sure, you can see the documentation by doing Shift and Tab. Random integer from low to high, and you can see at the bottom part, if you scroll down, if it's uniformly distributed. But the good thing is that in Python the errors are good. How are you guys doing? You need help? Yes, you want to do? Yes. um, no, no. The valid syntax would be to have the integer function at the outside, but instead of doing that, there's a function in NumPy called rand int, For example, let me show you. Sorry, yes, I didn't. Whoops. I requested to have the mouse to have whose computer it is it? I can't do it. But random dot rand int does the same, but instead of real interval, it just does integers. Yes. So instead of uniform, rand int. Rand. Run that. I'm a little slow, but random. Oh, you need to import random first. The first line must be from numpy.rand in the first cell to be a little bit more organized. Yeah, there at the start. Oh, you do it by with that plus código. No, from numpy. Yes. Import. No. From numpy dot random import, and here you can do shift tab, shift plus tab, or tab to autocomplete. No, it does not work. It should work. No, okay, but it's called int. That one. Yes. Now this in the second line you can remove the random dot. You can remove the first part. Yes. Okay, but instead of size none, you can put, for example, 100 or 1000. You need more numbers to do a histogram. Now it's too low, but run it to see the result. So there you have 100 integers between 1 and 6, but as you can see, it does not include 6. So your dice is missing one face. In Python, the end parts are always not included. Yes, the upper end part. The same happens with the indexation of a list. Do you remember that if you put between 1, 2 points, and 5, the 5 was not included? It's something that Python loves to do. Okay, so instead of just doing the function, try to save that into a variable. For example, called x1. And that x1 is your first dice rolled 1,000 times. You see? And you need to do that for x2. And then you need to see the histogram of the addition between the two dice. Yes, the same. As int is a random number generator, the same function, if you run it one time and you run it again, will give you totally different numbers. That's the whole thing about the random number generation. And now you need to do a set equals to the addition of both. Yes? Yes, it's okay. And now you need to do the histogram. The histogram was the bars in blue that I plotted in the previous. Yes. No, that one was normally distributed, and this one is uniform. But yes, obviously the first and the second dice are uniformly distributed random integers, but the addition of both, it will be uniform or not. You need to see that with the histogram. Normally distributed. But the histogram function does not change. The only part that changes is the second part where I plot the PDF. Yes, the hist function is what it does the histogram. But in your case, instead of x, is set. No? Oh, well, if you want. If you want, you can plot the first dice and the second dice. That means that the heights of the squares, or the bins, the heights will be probability. Or density, actually, not probability. Plot it and you'll see. Because you had yes, the y-axis. You had 1,000 numbers. If you plot the frequency, you'll have 1,000 divided by 6 in each y-axis. But if you put density equals to true, that part will be probability instead of number of occurrence or frequency. I'm not quite sure what it does. You could try. Did you click the cell? Maybe it's because you need to try to run it again. Run the no, the histogram part. Run it again. Probably it's because you need to show. Add a line in the same cell. In this cell, enter, show, W, and the parenthesis, that, and run it again. Yes. Oh, so histogram was not defined. That was the problem. You need to import the histogram function. And to do that, you need to... No, in histogram or the plot-related functions are part of matplotlib. So you need to do from matplotlib.pyplot import histogram. Yes, or another one. I'll send you the code in the chat. There. Copy and paste the histogram part, and that should be it. Yes, yes, is more organized. You also need to import the show function, but it's not relevant. You can delete the show function. The show part you don't need it in matplotlib. There. That's the histogram of the first dice. You do plot, and as is just 6 numbers, it's easy. You just do plot and square brackets 1 2 3 4 1 2 3 4 No, you were okay with the parentheses. The square brackets are to define the variables inside the plot function. No. Let me try to control your computer. Can you give me access? I requested to control your computer. I'm not. Now. The plot function, it's called with parentheses, but we'll use the square brackets to define the vector inside. I'm now defining the x part of the points, and the y part will be just once because it's uniform. But as I'm plotting the density, that needs to be divided by 6 because there are 6 points. Oh, you need to import plot as well. Here. Oops, sorry. Here. You add plot. You run the cell. And now you run this part again. Okay. Let me use arrays. The default lists in Python cannot be divided by an integer, so you need to convert it to an array to be able to do that. There. That should be everything. Oh, I think I didn't import array. Sorry if I'm a little slow. I have a little bit of delay. Yes? Yes? That was a mistake as well. There it is. As you can see here, the yellow line is the probability of each number, but it's not the same as the density. The density, I'm not quite sure how it's calculated. Let me see. There have 6 numbers. Let's put it as probability. Probability. I don't remember exactly how to change it to probability. Maybe I put false. Okay, when you do false, you are plotting the frequency of each occurrence. As you can see, the number 1 occurred 175 times, the number 2 150 times, and so on. So instead of putting just 1/6, you could put 1,000 divided by 6. And there. That's the expected result, and the histogram part is the blue bars. You now can continue the other parts, but I'm being requested by another group, so I'll be changing rooms. Okay. Hello. Okay. Yes. Hello. How is everything going? Are you leaving, Daniel? Oh. Well, I hope everything's fine there. Nice. Hello? Are you working in here? I don't see a screen share. You stopped recording? So you already did the dice part? Okay. Okay. I'll join the rooms now and explain a little bit about that problem, and then we'll skip the weird noise part and start doing the homework. Let's do that. Hello. Well, everyone is arriving now. I think I can just stop, close all the rooms. Okay. Uh, okay, everyone's arriving. I'll be explaining something about the dice. Oh, something's weird about this. Now. Now you should be hearing me. I was saying, I didn't say anything important. I just said that I'm waiting for the other people to arrive. Okay, I'm not sure why, but my tablet is doing some crazy stuff today, so I'll be drawing worse than usual. But basically, you have here a random variable called x1, and you also had another dice called x2, and you want to see how does the random variable, this is also a random variable, set equals to x1 plus x2 behaves, right? Obviously, the first variable, x1, has a uniformly distributed value between 1 and 6, and the x2 variable, it has exactly the same distribution. We'll call this distribution f of x as the probability of each occurrence of this. For example, here you have 1, 2, 3, 4, 5, and 6. The one thing I wanted to talk about is that when you add two random variables, what is occurring in the PDF space? Because if you already did the histogram, you basically obtain something like this. Something similar to a triangle. And here you have 2, and here you have 12. And at the mode of the distribution, you have 7. What is happening here is that you have two random variables, x1 and x2, with the same distribution, and what is happening here, I'm not sure if you have seen convolution in the course, But what is happening is that the distribution of, let's call it f of z is the convolution of f of x and f of x. So that's why you have a triangle in the histogram, because the convolution between two uniform distributions or rectangles, rect functions, is equal to a triangle. Okay, that was the thing I wanted to talk about. Here, this operation here is not multiplication but convolution. If you haven't seen convolution yet, this will make sense a little bit later. Okay. For the other parts, you can do it at home, and we'll see the solutions later. And we'll start with the homework. So for the homework, basically you had two exercises. Sorry, I wanted to open this tab. You had two exercises. The first one was about vectors. And you had basically two vectors, E1 and E2, and you have a transformation T that goes in a 2D plane to or R2 to R2, or just remains in a plane. And the transformation evaluated in these two vectors, or that are called unitary vectors, is V1 and V2. The first activity is to find a matrix, a 2x2 matrix, T, that represents this linear map. This is the first part of the homework. And another thing I want you to do is to relate the formula of the area of a triangle, this formula exactly, where you can see a relationship between the area and this size, for example. Oh no, in this one is in between this size B, the size A, and the angle C. And the area is 1/2 the multiplication between these two and the sine of C. Here you cannot see it, but I had another thing below. Well, you can see it here, but you need to relate this formula with the formula of the area of a parallelepiped with the sides defined by the vector x and y. So instead of being b and a, these instead are vectors x and y, and you have the other part. That's why you'll need to multiply this formula by 2, and you need to relate the vector formula with this very basic trigonometry formula. And the second part is about the second question of the homework, and it's about reading the file that the homework has and plotting the total cases for Chile and do an exponential fitting of the data. In the homework you need to do it for more countries, but we'll do it just for Chile here. As we don't have enough time, the first part I'll do it here. I'll just show you. And the second part we'll do together in groups. Let me see where. My keyboard is not working properly. No? No, it's not working. Let me stop the sharing and... No. Now it's working. Okay, so the first part was to have a linear map T that goes from R2 to R2, and we had that if you plotted the canonical vectors E1 and E2 in this space, the transformation T, basically what it does is to transform this to B1 and B2. For this, if you want to understand this better, I suggest you to see the video I put in the tutorial 3, I guess. I'm not completely sure about the number, but I'm completely sure that the video is from 3 blue, 1 brown. 3 blue, 1 brown, and it's about the linear transformations. That's in YouTube. But basically this is the problem. Mathematically you can write this as the transformation in E1 is equal to B1 and the same with E2. This vector E1 is 1, 0, and this E2 is 0, 1. The transformation T, as it is in the 2D plane, can be expressed as a 2x2 matrix. T is equal to AB. Oh, let's, instead of calling A, B, and C, let's call it T11, T12, T21, T22. Okay, so basically what you're having here is that this matrix multiplied by E1 or 1, 0 is equal to B1, but that at the same time means that when you multiply this vector by this matrix, you basically obtain T11 and T21. So you're basically sampling the first column of the matrix. That's why the columns of a matrix are the impulse response. That will make sense for people that have taken the course Signals and Systems. But basically you can sample the columns by using these canonical vectors. And if you do the same with the second canonical vector, 0, 1, you'll obtain B2, and that's equal to 1, 2, T22. Basically, that was the first part. And the second part was about relating the formula of having X, Y, and whoops, and you do the copy of that, the parallel copy. So this is parallel to this part, and this is parallel to this, X and Y. And basically you have this triangle here. That you have an angle here, theta. And the basic formula in trigonometry is that the area of the triangle is equal to 1/2 the length of the one side, that's the norm, times the norm of the other side, times sine of theta. And how do you arrive to that formula? You can derive it by basically doing I'm not sure how it's called in English, but altura. And then you can obtain the formula, or the height of the triangle. That's the word. But we don't have time, but I suggest you, for the people that does not understand where this formula came from, to try to do it. Try to do the proof. It's not difficult at all. And basically, the trapezoid here, or no, not sorry, the parallelepiped, I'm not quite sure how to say it, but this part here has an area of 2 times the triangle. Is equals to 2 times the area of the triangle. And this is the formula you obtained in the, or you got in the homework. The norm of the first vector times the norm of the second vector, and times the sine of theta, being this angle, the angle between the vectors. And how do you obtain this here? You already have seen that when you have 2 vectors that are parallel, and you do the dot product, basically that gives you the norms multiplied times 1. When you have the vectors perpendicular to each other, and this one is y, you give the dot products are the norms, but times 0. And this number here, 0 and 1, is the sine of theta. Here the angle is equal to 0. Here the angle is equal to 90 degrees, or 0 radians, or 5.5 radians. So basically, what the sine of theta is in vector relationships. Mm-hmm. Sorry, I messed up. Yeah, I messed up. Well, these numbers are correct, but somewhere I messed up here, but no, this is correct. When the 2 vectors are perpendicular, you obtain a 0, and this angle is 90. But this is not equal to the sine. This is not equal to the sine of theta. This is equal to the cosine of theta. So to get the sine, you need to do some operations with the dot product. I think the homework say to write that in terms of the dot product, but that's something you need to think. That's the first question. And for the second question, as you have more programming, I want you to try to do it now in groups. Okay, I just explained the first part so we could focus our time in the second part. But yeah, the dot product between 2 vectors gives you the cosine of theta, or being the theta angle, the angle between the 2 vectors, and multiply by the norms. And you need to see how this operation relates with the area. There's another vector operation that gives you the sine of theta. You need to think about that. Okay, so let's break the rooms and work the time we have left in the second part of the homework. Okay. Hello. Mm-hmm. Countries? What did you do? Mm-hmm. Mm-hmm. The parameter, yes? Mm-hmm. Mm. Do you have a notebook or something to show? I can help you. Have the others started working the homework? Esteban and Victor? Yes? Okay, did homeworks. Yeah. Um, yeah, why? Yes. Mm-hmm. Mm-hmm. Yes, it's wrong. You need to do a least squares model to fit the data. Try to do it in Python, it's easier. Did you do that by hand? All the data? Okay. Okay. Yeah, you can see the results in Excel and then try to do it in Python. But basically try to plot the to do it in Excel, obviously. Try to select the columns G and H. Select the columns G and H. Yeah, at the top. Clicking the G and the H. No, a little bit. No. Uh, Let me click it. Can I like that? If you select the letter, you select everything. This and you can try to plot your function. By selecting that, now you go to formulas and plots, I think, and you can plot the things for two. Do it right now. I want to show you something. Yes, that that one. Yes. Uh, okay, so that's correct, but it's transposed because the column time should be first. You need to move the time to the left. Move the that column to the right of H. Yes. Now do the same. Yes. Yeah, that's the number of total confirmed cases of the virus, and the x-axis is the well the time. What you need to do in the homework is try to fit a line to the logarithm of y. So Yes, so now, for example, instead of y, plot t with the logarithm of y. Remove that plot and create a new cell, a new column with the logarithm of y. Okay, so the h column equals to the logarithm of that. Yes. I think you can do that automatically by just double clicking the corner, but whatever. And now do the same, but and now you need to plot f and h. Okay, select f. That, yeah, that's correct. So basically, what you need to do is to do a linear fitting. That one, that line that you just draw is the linear fit of the logarithm of the total cases, and the slope of that line is the growth rate. So your beta factor is the slope of that line. Excel, what it does behind the hood to do that fitting is to solve a least squares problem. And that's what you need to do in the homework. Okay. Everyone else understood that? Yes. Python? You can read the CVS, no, I think it's CSV file by using the package Pandas. Pandas has a function called load CSV. You can try to show your screen, Esteban, so you can show everyone else how to do the things in Python. But Javier, what you had there, 0.12, the factor that is with the x is equal to the slope, and in this case is equal to the growth rate. Okay, and you need to do that for a lot of countries. Yes? Yes. Yes. Beta equals to 0.1245. Okay, so now Esteban will start sharing screen and start to doing that, but in Python. Okay. Let's see if you can import the data. I'll be changing rooms. If you have any question, you can ask for help. But yes. Ah, okay. So wait a little bit. I'll add Esteban to your group, but I'll be changing now. How are you guys doing? How are you doing? Yes. Ah, it is not, but it's a good practice to do it in Jupyter if you want. But what what would be better if you just sent a PDF file with all the results and the explanations, etc. And also, you could send the code in a Jupyter notebook or in a just regular Python file, however you want. Yes, but I'm not sure. You should try. Who's trying to write the code now? Nice. No, no, but yeah, yeah, the only thing you're missing is that you need to upload. Yes. What's that numbers file? Yes. I'm not sure. Yeah, yeah, that's the correct format. I, I wasn't sure why you had a that numbers file. That's a format in Mac OS or something like that. CSV. But 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 did you upload the file here? Oh yes, you have. Okay, so the problem basically is that file needs to be uploaded in another folder. If you go up in the folders, go up. Uh, what happens if you click the folder icon? That one? Yes, no, no, nothing. Let me say something. You need to go up in the levels a little bit. I'm not quite sure how did you arrive there. uh, mm, what happens if you click this and sorry and then update actualizar? Okay, because the problem is that the notebook is not reading that file because the notebook is in another folder. Mm, okay. Now I'm controlling the thing. Yes, I think. Mm, no, I'm not controlling the. Yes, but I cannot click. Yeah, that's weird. Let me try again. Now. Here in user. No, I can't click. I don't know why. Can you click user? Here. the last folder bar, then you have user. That. No, it's not that one. M and T. Sorry, up, go up, up. M and T. No, M, like mount. That one. It does not have anything. Go back to user. User, share. Oh. Yes. Share. I don't remember what's the URL. Can you refresh the page? Maybe if you refresh everything, it will select the correct folder. And that's the kind of problems. Yeah, no problem. Okay, so yes, now I can. This is the. I'm not sure where the file is, but you need to upload the file here. Total cases, this one? Yes. Ah. Okay. So I think now you should be able to run the file because it's in the correct folder. Let's go down very quickly. Oh, okay, yeah. Copy, paste the thing. Yeah, okay, now run the file. The cell, sorry. Now it's okay. Now you could read the file. Now you need to see how to properly interpret the file. Yes, Diego? Yes, you could use pandas if you want. Yes, you could use it. Yes, no problem. I'll be going to the. Sorry. Hello, Javiera. Let me close all the rooms. Sorry. Let me turn to mention this session. Okay, some people had to leave, so I'll be talking the last stuff here. Okay, Javiera had one of the last doubts, and yes, Javiera. Oh, sorry. Okay, so some people had classes, so they had to leave, but the last doubts we can solve them here. This will be uploaded as well, Javiera. Mm-hmm. Notebook. Okay. So share your screen and I'll show you because I had the same problem with the other group. So I know how to solve it. You are using the Google Colab. You can't share your screen? Okay, so I'll share mine instead. It's just quicker. Okay, let's share my screen. Now, I'm not sure why my keyboard is messed up. Okay, so here I have the folder. Oh, sorry, here I have the Google Colab. If you press the folder icon, something will open now. Let me reload the page because something happened. Okay, so if you press the folder icon, now it should connect. It's loading. Let me run this cell to see if no. Here. Okay, so here. Files, you have sample data. You can upload a file. For example, homework 1, total cases. And you're uploading the file as you can see here. And when it appears, you can open. Oh, I'm not sure why this keyword is not working. Open. And you can put total cases. That CSV. Entonces, with file as open for line in file print line. With file as open for can't assign function call open. Did I miss something? By default it should read, so this should not be necessary. Oh, I don't remember the syntax. Let me very quickly go to the last notebook. Or we can Google how to open a file very quickly. Yeah, I'm not sure what's happening. My keyboard and my mouse are not working properly. But can any of you see how to open a file? It was something as this, but oh, no, it's working. Okay, no, I have the tutorial too. I think I teach how to read files. Because I don't remember exactly the syntax and why it's throwing an error here and here. With open as file. Oh, I put it the other way around. Okay. It was it was with open as file. Sorry. Now it should work. Line. As you can see now, it's reading the file properly, and each line is exactly this. Yeah, there's a a lot of lines, but you don't need all of them. You just need the ones related with Chile, USA, South Korea, Italy, and other countries that I added. Yeah, so that's how you upload a file, and that's how you read the file. And for example, you can use this if line dot split the first part 0 equals to Chile print line, and now it will be if line dot split 0. No, I missed a quotation there, and now it should only print the lines related to Chile. Oh no, It was not called Chile. Maybe it was called Chile and then a space or something like that. Chile space. Well, I don't remember how it was called. It was called Chile or Chile and a space or something. Or we can do it the other way around. If there's Chile in this, now it's working. So if the Chile is inside the first string, you obtain this. Oh, I now I get it. Because it's not separated by spaces, it's separated by commas. So instead of this, you should have done comma. And then you can do equals. There. So this is all the data related only to Chile. Split, comma, and the end. Now I'm plotting only the numbers. No, sorry. I was plotting line split. Line splits -1. -1 is the last part of the line. As you can see, you have only the numbers. And for example, we can do index 0. If it enters here, index +1. And we can save this in a vector called covin of I equals to like that. So for example, from numpy import zeros. There. That way we saved everything in the vector COVID from matplotlib.pyplot import plot COVID. Okay, I had too many numbers, I think. Okay, I missed something here. No. What? Oh, sorry. This should be outside the for loop. Otherwise, it's being reset all the time. Index 20. Okay, 20 is too small. Let's put just 40 to guess the number of data points here. And as you can see, we have the total cases of Chile. And let's just plot that until the 25th number. So that's an example of how to do it. You didn't need to do that with other countries, but you could also do the, because in this part here I'm doing data filtering. You could also do that part with a package called Pandas. And you can do that by doing from Pandas import load CSV or something like that, and you can then select the country Chile. Let me write it Mm-hmm. 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 It could probably be because Pandas by default selects the columns, and the CSV is in rows. It's very weird how I put the CSV, and that was on purpose. Here. Now I'll print all everything. As you can see, Chile is in the rows. The columns are the other data here. So probably Pandas, what it does is try to, for example, the first line, call it the header, and then when you try to select Chile, as the first country is not Chile, it's not selecting anything. But there should be a way to select rows that contain. There should be a way to select rows in Pandas that contains the Chile part. I'm not quite sure how to do it, but you can Google it. This is the more. Not. Yeah, that's why you need to do it like this. Contains Pandas, and you select the Stack Overflow. So here there's a method to do it, but I'm not sure if this is selecting the rows. Select how to filter rows containing a string pattern. This is what you need. Yeah, you need to do something like that. Data frame, and then the IDs in a string that contains Chile, and that will give you all the information. Okay, that's everything for today. Any last questions or doubts? Remember to answer the survey. No? Okay, I'll stop. Yes? Okay, I'll stop recording then. The tutorial is officially finished. The title? That one is the. Okay.